I'm now moving on to question number 13 in the radicals review guide. And for question number 13, I need to arrange the following terms from least to greatest. So when you're doing a problem like this, I would change all the radicals into an entire radical. So if I have 3 root 5, this is a mixed radical. Let's go ahead and change this into an entire radical. And I can do that by taking the outside number here, which is 3, and putting that back inside the radical as 3 times 3, because that's a pair, and then the 5 remains. And if I multiply that out, I get root 45. Then let's take 2 root 7, and let's turn that into an entire radical. And let's do that by taking the inside number, which is a 2, and putting it right back inside the radical, so 2 times 2 times 7. And this is going to be, 4 times 7 is going to be 28, so root 28. So based on those two calculations, root 45 is bigger than root 28, so 3 root 5 is greater than 2 root 7. And then I have a 6. When you have a 6 here, if you want to change this to a radical, 6 is the same thing as root 36. So sometimes you need to change the number into a radical, so root 36 would work. And after that, I have 3 root 2. So for 3 root 2, let's go ahead and change that back into an entire radical. That's going to be a 3 times 3 times 2. And that's going to be, 3 times 3 is 9, and 9 times 2 is going to be 18. So root 18 on that one. And then finally, the very last one, I have 3 root 3, and I will do that over here on the side. The reason why I'm going to do this on the side here is because you need to rationalize the denominator for this problem. So if you want to rationalize the denominator, you want to times top and bottom by the radical on the denominator. And if I multiply straight across, 3 times root 3 is 3 root 3, and 3 times 3 is going to be root 9, and root 9 is going to be 3. So then these guys can cancel off, and you're left with just root 3. Okay, so 3 divided by root 3 is going to be simply root 3. And so let's just write that at the very bottom here. So 3 divided by root 3, if I simplify that down completely, I get a root 3. And once you've written everything in terms of entire radical, then you can compare the inside numbers here, and that way you can find out which radicals are the biggest and which ones are the smallest. So if I'm going from least to greatest, I believe root 3 would be the first, so it would be 3 over root 3. And then after that, I guess root 18 is the next one. So root 18 is going to be 3 root 2. And then after that, it's going to be root 28, which is going to be 2 root 7, so 2 root 7. And then it's going to be a 6. And then it's going to be root 45 is the biggest. So that's how I would arrange. Well, sorry, not root 45. It's going to be a 3 root 5. And that's how I would arrange this from least to greatest. Okay, let's go to question number 4, rationalize the denominator. So this is the kind of the concept that was used to simplify the last radical in the previous problem. If you're rationalizing the denominator, just take a look at the radical on your denominator for each expression, and you just times top and bottom by the denominator. So 15 times root 5 is going to be 15 root 5. And 5 times 5 is going to be root 25. And root 25 is going to be a single 5. And then the top is going to be 15 root 5. And then from there you can simplify the 5 and the 15. So that's going to be a 3 and that's going to be a 1. So this is 3 root 5 as a final answer. Okay, let's move on to question number, the second question here. So if I have a big radical sign like that, I can reduce that into 2 individual radicals. So root 2 divided by root 7. And then let's times top and bottom by root 7. And 2 times 7 is going to be root 14. So 14 there. And root 7 times root 7 is going to be just a single 7. So root 14 divided by 7, that's how you can rationalize the denominator. Rationalize the denominator means you just can't have any square roots on the denominator. Okay, let's move on. Question number 15, let's simplify the following expressions here. So I have an odd power here and I have an odd power there, so we can rewrite this. So we want to change this to an even power, and we can do that by decreasing the power by 1 and then timesing by x. And then y to the power 7, I can decrease the power by 1, so y to the power 6, there's my even power, times by a y. And then from there, let's go ahead and calculate the even expressions here. X to the power 4, since that's an even power, divide that by 2, so y squared. And y to the power 6, if I divide that by 2 on the power, I get y to the power 3. And then I have the x and the y left over, so then I just leave that on the inside as x times y. And that's it for that question. Let's move on to the next one here. Okay, so there's a 24 here, so let's go ahead and take care of the 24 first by using a tree diagram. So 24 is the same thing as 8 times 3, and 8 is going to be 4 times 2, and 4 is going to be 2 times 2. And let's go ahead and box all these prime numbers here, and there's a pair. So if I collect all the pairs here, this will be 2 root 6. Okay, so how does that work? Well, there's a 3 here, so let's put the 3 over here. And now let's look at this 2 root 6. The way we're going to put that in here, sorry, let me just redo this here. Let's put the 2 root 6 like that, and then this 3 can come out there in front, so 3 times 2. And then I have an x to the power 6. And then I have an odd power here, so if I want to change that, that's going to be y to the power of 4 times y. Okay, so that's how we're going to rewrite that expression there. And then from there, I guess we can just simplify this. 3 times 2 is going to be 6. I guess that 6 can remain. And then I have an even power here, so that's going to be x to the power of 3. Another even power there, which is going to be y to the power of 2. And then this y can go back inside the radical sign. So my final answer is 6 times x cubed times y squared times root 6 times y. So that's my final answer for that particular problem. Okay, I got a few more questions to go and then I can finish this video here. For the next one here, let's take the outside terms and multiply them together. So 3 times 2 is going to be 6. And x squared times x cubed is going to be x to the power of 5. And then if I take root y times root y, well, y times y is going to be y to the power 2. And since I have an even power here, that just simplifies to a single y. And then I have the 6x to the power 5 in front. And that's my final answer there. Okay, let's move on here. We're almost done this video guide. So let's take care of the numerator first on this next one here. So if I take care of the numerator here, 6 times 6 is going to be 36. So root 36 there. And x to the power 6 times x to the power 2 is going to be x to the power of 8. Divided by 9x to the power of 8. And then from here on, what about root 36? Root 36 is going to be a 6. And x to the power 8 is going to be x to the power of 4, because even powers you divide by 2. And then on the bottom I have 9x to the power of 8. And then from here you can just simplify this. 6 divided by 9, I can divide top and bottom by 3, so that's going to be a 2 and that's going to be a 3. So we get a 2 there and a 3 here. And if I have x to the power of 4 and x to the power of 8, well, if I expand the numerator, I have 4 x's. And then on the bottom I have 8 of them. And what's basically happening is you're just getting rid of all the common ones, and you'll see that you have 4 x's surviving on the bottom, keyword bottom. So the final answer here is going to be 2 divided by 3 x to the power of 4. Okay, let's keep on going here. I guess there's one last question to go and then we're done. For this particular problem, you have a radical divided by a radical, so we can create a bigger radical. And on the inside, I can have 15xy to the power 5 divided by 5xy. And let's just divide the numbers with the numbers. So 15 divided by 5 is going to be 3. And then those x's can cancel off. And if I have y to the power 5 divided by y, that's going to be y to the power of 4. Remember, you have 5 y's on the top and 1 y on the bottom, so those can cancel off and you have 4 y's remaining. Now we're not done yet because there's still a square root sign there, and this part here there's an even power, so if I pull that to the outside, that's going to be y to the power 2, and then root 3 will remain. And that's your final answer for that problem.